All right, today's short Wednesday video is number 51 on page 676. So if you want to go ahead and pause and copy it down, this essentially is the gist of it, where we have a triangle kind of within a triangle. This angle right here is 30 degrees. This angle is theta. We don't know it. But for the smaller triangle, we know the sides, 5 and 12. So 5 pretty much stops here. So we're going to be using our sum and difference identities in order to figure this out. And really the only thing you can find out right now is from this smaller triangle. So if we just pull that one out, we don't know the angle theta, but we know that we have the side opposite of it is 5 and this side is 12. And we can find the hypotenuse. So when we find the hypotenuse, we use 5 squared plus 12 squared equals c squared. This is 25 plus 144 equals c squared, and so c squared equals 169. And if I square root that, I get c equals 13, and we're just going to go with positive numbers because it doesn't say what quadrant it is in, but we have 13 there for hypotenuse. And so here's what we do know right now. We know that cosine of theta is 12/13 from this triangle. We know that sine of theta is 5/13, and we know that tangent of theta is going to be 5/12. And all of that we get from the smaller triangle within the outside. So here's what we know. Here's what we want. We want sine, cosine, and tangent of this bigger angle A. And we can say that angle A is really 30 degrees plus theta. And we don't know theta. So we're going to use some of our sum and difference identities to find what sine of alpha is, because we do know something about theta. We know the values. So we want sine of A, which we just said is going to be sine of 30 plus theta. That is my alpha, that's my beta. And if I plug that into the sum identity for sine, I get sine of 30 times cosine of theta plus cosine of 30 times sine of theta. And we have all those values. On a 30, 60, 90 triangle, we know that sine is 1/2. And we know that cosine at 30 degrees is √3/2, because those are the values from our unit circle. And so we also know cosine of theta is 12/13 and sine of theta is 5/13. So we now can solve for sine of A. Sine of 30 is 1/2 times cosine of theta is 12/13 plus cosine of 30 is √3/2. And then we have sine of theta is 5/13. So when we simplify this, 1/2 times 12/13 is 12/26 plus 5√3/26, or that can all be simplified to be 12 plus 5√3 all over 26. That is sine of alpha, or sine of A. So now we can go ahead and find cosine of A, we know that cosine of A is made up of, sorry about that, is made of cosine, sorry, I don't have like a good flat surface because my thing that holds my camera up leaves a bump. So we have cosine of 30 degrees plus theta. And that equation is cosine of 30 degrees times cosine of theta minus sine of 30 degrees sine of theta. Right, so cosine of 30 is root 3 over 2, and that is being multiplied by cosine of theta, which we found up here is 12/13. And sorry, my lead, of course, right in the middle of a video is running low. So we have 12/13 minus sine of 30 is 1/2 times sine of theta is 5/13. And that all is going to be 12 root 3 over 26 minus 5 over 26. And so we know that cosine of A equals 12 root 3 minus 5 all over 26, or you could have written it the other way, -5 plus 12 root 3 over 26. Right, so here's a summary of what we have so far. You might want to pause and take this down before we head into tangent, because tangent, from, if you guys remember from Monday, Tuesday lesson, tangent's harder because it's got a numerator and a denominator in its sum identity. All right, last but certainly not least, is we want to find tangent of A, which is tangent of 30 degrees plus theta. And that identity is tangent of 30 plus tangent of theta all over 1 minus tangent 30 times tangent theta. And we haven't found tangent theta yet. Actually, we did. We came up here and we said it was 5/12. What we hadn't found was tangent of 30 degrees. So we know tangent of theta is 5/12, and tangent of 30 degrees is sine over cosine, which is 1/2 divided by root 3 over 2. And that simplifies to be root 3 over 3. Okay, so now we're going to plug all those values in. And you can see how it can get ugly really fast. Having a denominator of 12, denominator of 3, and that's just in the numerator. So tangent of 30, we said, is root 3 over 3. Plus tangent of theta is 5/12. That's in my numerator. In the denominator, it's 1 minus that root 3 over 3 times 5/12. So now if I find a common denominator up here, 4 over 4 for that, in the numerator, still working on that lead situation, in the numerator, I'm going to have 4 root 3 plus 5 all over 12. And in the denominator, first step is 1 minus 5 root 3 all over 36. Right, so we're going to do some more common denominator magic. I'm going to multiply 1 by 36 over 36. So at this point, tangent's just a lot harder, you can see. 4 root 3 plus 5 all over 12 in the numerator. In the denominator, I'm going to have 36 minus 5 root 3 all over 36. Now I'm going to take the reciprocal of that denominator and multiply. So I get 4 root 3 plus 5 all over 12 times 36 all over 36 minus 5 root 3. 12 goes into 36 3 times. So when I distribute this 3 to both the 4 root 3 and 5, in the numerator I get 12 root 3 plus 15 all over 36 minus 5 root 3. Right. And that is as far as you can go. So this is tangent of A. It's a little bit different value radical-wise than what you see in the book if you were checking your answers, but when you plug it in and you find the decimal answer, it's exactly the same. So I know this video is getting kind of long, but here's zooming out for tangent if you want to pause and copy those notes down. Here's sine and cosine again if you want to pause and get those. And then here's the beginning. So I want to make sure we had a chance to see everything. All right, there's a short assignment that goes with this, and then don't forget the Thursday, Friday assignment. Hope you all have a great spring break.